Hello guys, welcome to Pepcoding, and now we are going to discuss the next problem, that is diameter of a binary tree, all methods. So we have already done this question in our level 1. So in this video we are going to discuss all the methods which are possible in a diameter of calculating the diameter of a binary tree. Okay, so let's discuss how can we do this. So before discussing the approach, first I'm going to tell you about what is the diameter of a binary tree. Okay, suppose diameter is actually the two ends, the length of two ends of a tree. See, so suppose you have to calculate the diameter of this tree. Okay, so the longest distance is 972,135. That is 1 2 3 4 5. So 5 is the diameter. When you spread these node, this is going to happen like this: 7 8 2 1 3 5. Okay, so it can be this node. Suppose there is one more node, that is 7, or you can say 81, so it will attach 81. So this is actually the diameter, that is 6. 1 2 3 4 5 6. Okay, so the length of the maximum length of one end to the another end, the maximum height is the maximum length is the diameter. Okay, so the diameter of this node is 1 2 3 4. Okay, 4 is the diameter, and for this node diameter is 1 2 3 4 5 6, or you can take this also, 1 2 3 4 5 6. That is actually equal 6. So the maximum diameter is the final diameter. Okay, this is how we calculate the diameter, and it is not compulsory. Like, the maximum diameter is only lies in the root node, it is not compulsory. Okay, it can be possible, like in this case it is possible, like our diameter lies in our root node. Okay, so let me take some another example where we will see how it is not possible. See, let me create one more, add some more 21 and 22, 23 and 24. Okay, now let's calculate the diameter of this. So what is the diameter of the root node? 1 2 3 4 5 6 7. 7 is there. And what is the diameter of this? 1 2 3 4 5 6 7 8. See, now in this case the diameter is 8. The diameter is 8. That is actually for this node. So it is not compulsory that maximum diameter lies in our root node. Okay, so it is not compulsory. It can be possible. There are chances where it is possible, but it is not always possible. Okay, so now you have to keep this thing in mind. Okay, so we have already done by using how can we, let's discuss how can we calculate the diameter. So what we have to do for calculating the diameter, what we simply do is, what we have done is, we have just calculated the left diameter, okay, and we have calculated the right diameter, and we have calculated my diameter, that is the diameter of myself, my diameter. And how can we calculate my diameter? My diameter is actually the left height plus right height, and you have to add these two nodes also. See, the left height is 1 2 3, right height is 1 only. Okay, and what we have to do, we have to add these two, because we have to add these two nodes, 3 plus 1 plus 2. Okay, so we have to add these two, 3 plus 1 plus 2, that is 6. 1 2 3 4 5 6. This is how we calculate my diameter. Okay, and in the end what we have to do is, we have to take the maximum of these all. Okay, so in the end we have to take the maximum of all these, maximum diameter of all these three. Okay, so this is how we can calculate our diameter. So let's discuss it, let's see, and first I'm going to implement this. So now I'm going to implement our old method which we have already done. Okay, then we are going to implement with a new method. Okay, so let me go and write the code. So for this we have to calculate the height. Okay, so first I'm going to calculate height. So let me write the function for height. So how can we calculate height? So let's see it here. So I think you guys already know how to calculate height. So for height we simply use root is equal to null ptr. Okay, if root is equal to null ptr, then what we have to return? We have to return -1. Else what we have to do? We have to put the call. Okay, so max, we have to return the height. Return max of left height as well as right height. So for this we have to call it height of root of left and height of root of right. Let me do it full screen. So we have to calculate the maximum of these two, and in the end we have to add by 1. Okay, so this is how we calculate the height. And simply what we have to do for diameter, what we have to do, see, for diameter, so for diameter we have to calculate the diameter of left diameter, right diameter and my diameter. Okay, we have to calculate these things and we have to take the maximum of these things. Okay, so first we are going to calculate the left diameter, then we are going to calculate the right diameter. We are just simply using the call, we will use the faith. Okay, and then I'm going to calculate my diameter and I'm going to return the maximum of these three. So this is how we calculate the diameter. This is how we have calculated the diameter. We have already discussed all these things. Okay, so let me do this. So for calculating the diameter, first I'm going to I'm going to handle the base condition, that is if root is equal to null, that means we have our diameter is equal to 0. Okay, so now I'm going to calculate the left dia. So left dia is equal to diameter of a binary tree root of left. Okay, and then I'm going to calculate the right dia. So root of right, that is rd. Okay, so this is how we calculated the left and right dia, and now I'm going to calculate my dia. Okay, so how can we calculate the my dia? So my dia is calculated by the left height, right height plus 2. Okay, so this is the formula of my dia. Left height plus right height plus 2. Okay, so for this we also have to calculate the left height as well as right height. Okay, so for each node we have to calculate it. So left height is calculated by the height function. Okay, so first I'm going to calculate the left height, that is root of left, then root of right, that is actually the right height, and in the end how to calculate my dia, that is left height plus right height plus 2. Okay, so this is how we calculate the my dia. Okay, we have already discussed this, and then in the end we have to return the maximum of all these three. Okay, return the maximum of all these three. Okay, so first I'm going to take maximum, and then I'm going to take maximum of left dia and right dia, and maximum of these three, that is my dia. So then I'm going to take the maximum of these three, that is left dia, right dia and the my dia. Okay, so we have calculated it. Now let's see what is actually the problem we are facing in this. Okay, so let me take this and let's analyze this. So let me erase this first. Okay, now I have erased Let me take this. Okay, so this is our code. So for this, how we are doing this? See, for this, if you have to calculate it, so first you are going to give the left call. That is for the diameter of a binary tree. That LD. Okay. Then again you are going to give the left call. Then again you are going to give the left call. And then when you give the left call, then you got the null. Then you will find 0 in the left diameter. Okay. This is for 8. And then for the right diameter, you will find 0. Then what you are going to do? Then you have to calculate the left height as well as right height. Okay, so then you have to calculate the left height as well as right height, and again after that you have to calculate the diameter. So what will be the diameter? Left height will come -1, right height will come -1, that is -1 plus -1 plus 2, that will become 0. Okay, so our my dia will become 0. So 0 is going to return. Okay, and the maximum of all will be the 0. Okay, so 0 will be the diameter for this node. Okay, now let's see for this one. So now for 6, what is the diameter? Diameter is actually 0, and for right diameter is actually, what is the right diameter? Right diameter is also the 0. Okay, because when you give the call for to the right, then it is going to come null and we have to return the 0. Okay, so left and right is again 0. So what will be the height? -1, -1 from this side and 1 from this side. Oh, sorry, 0 from this side. Uh-huh. Okay, so now we have to calculate the left height as well as right height. So what is the left height? Left height is actually 0 and right height is actually -1. Okay, 0 and -1. So we have to calculate my dia. So left height is 0 -1 plus 2, that is 1. Okay, so for this the diameter is actually 1, because we have to take the maximum of all these. So for this we have to return 1. 1 is actually diameter, and you can see also 1 is the diameter. Now we have to calculate this for this level. Okay, so what will be the diameter for this? So the diameter we have already calculated, that is 1 for left hand side. And what is the diameter for this side? So again we have to give the call from this side. Okay, the diameter will be 1. Okay, so how can we calculate the my dia? My dia is calculated by just +2. So my dia is 4. Okay, and you also have to calculate these height also. So what will be the left height? That is 1. That is 1. And by left height, right height, you have to calculate the my dia, that is equal to 4. And you have to take the maximum of all these three: first, second, third. The maximum is 4 only. So this is how you have to calculate. So you have analyzed one thing, one problem. Actually we are facing one problem, that we have to calculate the height in for each and every node. See, again and again we are calculating the height. Again we are calculating the height. Again we are calculating the height. When we reach here, again we are calculating the height for this side and this side as well. So these two functions are actually running again and again. So this is actually a critical problem. So we have to rectify this. So how can we rectify this? See, let me just erase all the thing. So what I'm going to do is, first I'm going to create one tree. That is 1, 2, 3, 4, 5, 6, 7. Okay, 8. So I'm going to rectify one thing, that in for each and every node, like each and every node, I'm going to store the two things, that is diameter as well as height. And how can we store this? By using the heap memory. You can use the heap memory by using two things, that is one pair class, and another one is by just using the vector. Okay, so this is how you can use these two things. Okay, so for in this video I'm going to use vector. Okay, so I'm going to use the vector heap memory. So what I am storing in that vector, I'm going to store the two things. That is, the first thing is the diameter. diameter of that particular node. Okay, so for this, suppose I'm going to find the diameter, so it is actually the diameter of this tree, and for the right side it is going to store the diameter of this tree. Okay, so what is the maximum possible diameter up to this level? This is what I'm going to store. Okay, first I'm going to store diameter, and the second thing is I'm going to store the height. Okay, so we don't have to travel, we don't have to calculate the height again. We just simply retrieve from this vector. So this is what the actual idea which I'm doing, I'm trying to do. Okay, so let's see how can we do this. So I will simply take one vector in which I'm going to calculate the diameter. That is the maximum diameter. I'm going to store the maximum diameter for each and every node. Okay, so for myself also, I'm going to store the maximum diameter. And what is the maximum diameter? Left dia, right dia, and my dia. The maximum of these three is the maximum diameter. Okay, so this is what we have to store in diameter. And what we have to store the height? So a height is actually the maximum of left height and right height plus 1. Okay, so let's do this, and after that we will get some much better insight. So let me just try to code this. Okay, so for this I'm going to make some changes. This is our method. Okay, and let me remove this also because this is not a good efficient method. So let me take one function that return actually the vector diameter. Okay, it is going to take one argument, that is pre-node root, or I am going to take node. Okay, so now I'm going to calculate it. And what is the vector? Vector is actually the diameter, maximum diameter, max diameter of that particular node, comma, second thing is height. Okay, height of that particular node. This is what I'm going to store. Suppose if node is equal to null, that means we are in a base case. Okay, if node is equal to null, then height will be -1 and diameter will be 0. So I'm going to write in 0th index there is diameter, and in 1th index there is our height. Okay, so this is how we are doing. So if node is equal to null, PTR, that means we are in our base case. Okay, so for this we have to return the diameter with 0 and minus with 1 with a height. Okay, so this is what we are doing. Now for this, first I'm going to calculate the left diameter and right diameter. Okay, so first we have to set our diameter and height. Okay, so now I'm going to set my diameter as well as height. Okay, this is what we have to return. So how can I set the diameter? Okay, so let me set our diameter. What is our diameter? Okay, what is our diameter? See, let me calculate it. Let my dia. What is my dia? So my dia is actually the left height, right height plus 2. This is what my dia is. Okay, so how can we calculate the my dia? So for calculating the my dia, we need these two data. Our left data as well as our right data. That is vector. We need the left vector as well as right vector. So we also have to use the calls. Okay. So let me use the calls, that is vector of int left data, that is we simply use this function, that is node of left. Okay, and also we are also doing the same thing to the right, that is right data. Okay, so we have these two things, the data of left one and the right. Now we can retrieve the diameter as well as height. Okay, now we can retrieve this. Okay, now let's do this. How to calculate my dia? My dia is actually the left data height, that is 1, plus right data height, that is 1, plus 2. This is actually the my diameter. Now we have to calculate our final diameter, because we are not just storing the diameter of myself. I'm going to store the diameter of final diameter. I'm going to store the final diameter. That is the maximum diameter. Okay. So how to calculate the maximum diameter? We have to take the maximum of all these three. Okay. So we have already discussed this. Okay. So now I have calculated my diameter. Now final diameter, final dia. So I'm going to take the maximum of all these three. So max of left data 0, that is left dia, comma right data 0, that is right dia, and with the my dia. Okay, so this is how we calculate the final diameter, that is the maximum diameter. Okay, now we have calculated the final diameter. Now I'm going to calculate the my height. Okay, so for height we simply use HEIGST, height. So how can we calculate the height? Height is actually the maximum of max of left height plus comma right height plus 1. Okay, so L data of height we have stored in 1, and R data height we have stored in 1, and then we are going to add 1. Okay, so now we have to return my vector, that is final dia comma height. Okay, this is what we have returned it. So let's see what we have done. So first we have used this null pointer, we have handled this base case, then we have taken the data for the left data and the right data. Okay, then what we have done, we have calculated the final diameter. Okay, what is our final diameter, then our final height. Again we are storing it for myself and I'm going to return it. Okay, so this is how we are calculating it. So let's run this and check for the compile time errors. So let me run this and check for the compile time errors. So it is actually not printing anything. Okay, so for this we have to call it from here. So we have to return the diameter. So how to return the diameter? Simply I'm going to call this, and the 0th index is our diameter. 0th index is our diameter. So I'm going to return it from here, and now I also have to print it, because see from here, see out. So I'm going to call this function, that is root. I'm going to print it from here. So now let's run this. Okay, so it is accepted, and let me take this code and let's discuss for a 2 minute. Okay, let me take this code and let me discuss it for a 2 minute, so that you can able to understand very easily. So this is our final code. Okay, so let me take this and let's see what actually we are doing. See, what we are doing is, this is our code and let me erase it and let me simply create a new one. Okay, so this is our first, second. Okay, now we are going to calculate the diameter. So for this, again, first I'm going to check it whether the node is null or not. Not, it is not. Then I have calculated the left data. So again, it is going to calculate the left data. Again, it is going to calculate the left data, and in the end, it is null. When it is null, then it is going to calculate the right data. Then again, it is a null. Okay, so it is going to return 0 minus 1 0 minus 1. Okay, so it is going to return these two things because these are null. Okay, this is our diameter and this is our height, diameter, height. So now we have to calculate our diameter. What is my diameter? Is left dia of minus 1 plus minus 1 plus 2, that is 0. My dia is 0 and final dia will also become 0 because the maximum of all these three is 0 only. And let me calculate the height. Height is minus 1 plus 1, that is minus 1. Maximum of these two is minus 1 plus 1, that is 0. And 0 comma 0 is the final vector. Okay, so now we have used the left, now we are using the right. Right is null, so it is going to return 0 minus 1. Okay, now we have to calculate for myself. Okay, that is for 4. So for 4, how can we do this? Do it right now. So for this, we have to calculate the our my diameter, that is actually the 1 of 1. So my diameter is calculated by the left height plus right height, that is minus 1 plus 0, that is minus 1 plus 2, minus 1 plus 0 plus 2, that will become 1. Okay, now final height will also become the same, and now we are going to calculate the maximum height, that is actually the these maximum of these two, that will be equal to 0 only. Okay, so height will become 1. Okay, so see, in this method what we are doing is we are calculating, we are storing the height and diameter of each level. Okay, so we are storing the diameter and height of each level. See, this is diameter, this is height, this is diameter, this is height, this is diameter, this is height. And when we are in a root node, we don't have to calculate our height separately. There's no need of calculating the height separately. We are simply asking from this vector, like what is the height, what is the height, and what is your maximum diameter, what is your maximum diameter. And then with the help of these two data, I'm going to calculate myself and I'm going to return it for my node. Okay, so this is how the basic concept is going on. Okay, so let me submit this code and check for all the test cases. So all the test cases are running fine. So guys, thank you for watching this video and we'll meet you in the next video.